Okay, chapter 2.2, sketching graphs that satisfy given conditions involving limits. First off, today's activity that we're going to be doing live in class is going to be actually teaching this. So if you are going to attend the live session for Tuesday, September 22nd, whatever, when we're doing this lesson, you don't actually have to watch this video. It'll be optional for you. You can, it's bonus, but I'm really making this video so that if you missed the live session, you'll have something to go off of. So in the live session, I'm going to give you a bunch of limits, and I'm going to ask you guys in a group to get together and see if you can sketch a graph, a single graph, where all those limits are true in the graph. Now, this tends to be something that's learned really well through group work, through talking to each other, and like actually interacting. So preferably be at the live session, learn it live. If you want to watch a video and be at the live session, awesome, both. The more the merrier, better. But if you couldn't make the live session, this video is especially for you. All right, I hope I'm clear. So since these are the problems we are going to do in the live session, for my video, I'm just going to change some of these. Let's say that's actually, I don't know, 5, and let's make this one infinity, something different. Why not make that 0, and let's make that, 5 again. And let's make this one negative infinity. Sure. So the goal is to sketch a graph where all those, that satisfies all those different conditions, that satisfies all those limits. The big thing to remember when you're sketching these graphs is that these limits tell you about specific parts of the graph, but it doesn't tell you about what happens in between those parts. And for those areas, you can make up whatever you want. So I'll give you an example. For this, I know the limit as x goes towards negative infinity should be 5. So at 1, 2, 3, 4, 5, I know as I go further and further to the left towards negative infinity, this function's getting closer and closer and closer to 5. It's got a horizontal asymptote at 5. Now, I don't know if it's approaching from the bottom or approaching from the top. It doesn't tell me, so I can just choose whichever I want. I'm going to say it's approaching from the bottom. So I know I got a horizontal asymptote right here at 5, approaching from the bottom. I think I put that a little too high up. Let's actually add it and find out. It's a sketch, so it's all right. So there's 5, horizontal asymptote. There we go. That little arrow there, check that box off. Then I don't know anything about the function until 0. I know the limit of f of x as x approaches 0 is infinity. So 0 is right on the y-axis. I know at the y-axis I'm going to be suddenly shooting up towards infinity. Not just on one side, but on both sides, because remember this isn't a one-sided limit, it says it's from both sides, so both sides are shooting up towards infinity. This spot in the middle, it didn't give me any information about that, so fill that in with whatever you like to. If you just want to make it a nice connection, great. If you want to have fun with it and go like this, woo, great. Just make sure whatever you do, it's a function, like don't do this, because then it's not a function anymore. This time I'm going to just be simple. All right. So that first one's done, the second one's done. You notice I'm checking these off as I do it. That's a kind of a good idea to make sure, hey, I did those. All right, the next, as x approaches 3 from the left, so I'm gonna need a 3, 1, 2, 3. From the left side, it's getting closer and closer to 0. Well, 0 is right here, so I'm getting closer and closer to that part. I don't know what happens there. Maybe there's a hole, maybe it's actually there, I don't know. I'm gonna leave it blank for now. But I know from the left side, it's getting closer and closer to that spot. Again, I don't know what happens here, so do what you like. I'm just going to go like that. Why not something easy, something simple? All right, that part's done. From the right side, I'm approaching 5. Okay, well, so here's 3 again, that spot right there. I'm approaching 5 from the right side. So I'm going to put a little hole there. And from the right side, I'm approaching 5. Now, again, these are limits, so it didn't tell me what happened right at 3. You can feel free to put in whatever you want. You can say, nothing happens at 3. Or you might say, nope, at 3 we're equal to 0. Or maybe you want at 3 equal to 5. It doesn't matter. I'm going to make, when I put a 3 in, I'm going to say I get an actual 3 out. I'm going to say there's a little dot there. Sure, doesn't matter. Limit from as I approach 3 from the left is still 0, right there. Limit as I approach from the right is still 5 right there. So I'm good, right? And last thing, as x approaches infinity, my function's dropping down towards negative infinity. So that means on this side of the function, I definitely know it's dropping down towards that. I don't know what happens between here and here, so you just make up whatever you want. I'm gonna say I do something fun this time. Let's go up, down, and then we drop towards infinity. Excellent, whatever you like. Oops. All right, oh, there should be something I should mention here. There we go. This would be bad if I had this here and that there, right? Because all of a sudden I've got two things that's overlapping. I want a single function. So I'm going to erase this if I want the other one there. Every now and then I see people doing things like they'll make it like all sorts of things that are overlapping. When you're done, you should see one solid function. Well, not solid, it's going to have discontinuities, but one function that you can follow from left to right. Like this function starts here, goes here, and then it jumps like that, and then it goes like this, right? Like we should see all of this stuff so you can follow it and say, yeah, that's definitely one function with a bunch of discontinuities. That's one function. All right. Oh, I forgot my vertical asymptote. And my horizontal asymptote. It's good to have those in there. All right. That's the goal. I'm going to do one more example with a few more different conditions, but I mean, that's essentially the lesson for today is, hey, sketch a graph that meets a bunch of different given criteria. All right, if you want one more, here's one more. Again, this is the one we're going to do in class, so I'm going to change these up. I'm going to say that's x squared. Let's say g of -3 exists. I don't know why it wouldn't. Oh, it's weird that it wouldn't. Let's just take that off the target. Oh. Let me see. Yeah, let's say it exists. And then let's say instead of being 0, let's say that's -2. Instead of 0, let's say that's 4. Let's say that one's 0. And let's say this one is, I don't know, -1. All right, so start with my end behavior model. End behavior model is x squared. That means I know my top, my left and right, like here's x squared. I know my right-hand side is going to look like this. And I know my left-hand side is going to look like this, right? Because that's what x squared looks like. So first thing I'm going to do is say, all right, that's my end behavior model. I know the right-hand side goes up. And I know the left-hand side goes up, just like x squared does. All right, that checks this off. G of -3 exists. So that means when I plug in a -3, I get something out. It doesn't say what, so I'm just going to say, let's say I get a 3 out. Sure. If it didn't exist, I would just have to make sure that there was a hole there or an asymptote there or something else indicating that you couldn't put a -3 in and get something out. But this one exists, so I'm going to say, just make sure it exists. There we go, done. The limit as I approach -3 is -2. All right, so then that means as I'm approaching -3, even though I've decided it exists up here, it actually is going towards -2 right there. So from the left side and from the right side, right, because that's not a one-sided limit, it's both. From the left side and the right side, it's going to go towards that -2, that hole right there. Again, it didn't give me any information for between there and there, so do what you like. I'm just going to connect it up because why not make it easy? And then let's keep going. G of 0 is 4. That means when I plug a 0 in, I get a 4 out. All right, that's easy enough. 1, 2, 3, 4. Put that point there. G of 2 is 0. All right, so when I plug a 2 in, I get a 0 out. There we go. And the limit of g of x as I approach 2 from the right is -1. So from this right-hand side, I'm going towards that spot, right? It didn't say from the left, just from the right. So like all of that needs to happen. But again, we got to make this, you don't just leave it like that. Like that's a weird finish to the function up. It didn't tell me what happened between this part here and that part there. So connect them or do whatever you like. In this case, I'll probably say it goes up to there, goes down to there, Then you jump to that hole because that's there, and then these ones connect there. There we go. After you do these, it's nice to just go through and make sure it's all true. Is the n behavior x squared? Yeah, it looks like that. Does g of -3 exist? Yeah, it does. Check all these off the second time just to make sure, especially if it was a test or quiz, it's a good idea to make sure you didn't, erase something unintentionally and make one of those not true anymore. All right, that's it. Your assignment is just practicing that. 55 through 57 and 68. Good luck. See you later.